All right, so hi everyone. Welcome to the EECS Department Orientation. We're so excited to have you here. We wish we were on campus, but this is good too. My name is Andrea Mejia Valencia. I'm an undergraduate EECS advisor. So happy to have you here, like I said. And so just quick reminders to get started. The presentation, I'm sharing it with you all. Remember that you can double click on the presentation to make it larger. Also, if you want to hide the chat for a little bit, you can click on the little line and little arrow right next to the time left at the top of the leave button to hide the chat and make the presentation even bigger. Please know that the PowerPoint will be emailed to you. I will be sending an email to you this afternoon, including a lot of other information that will be helpful to you, and the slides will be in that email. Very important, we are using the chat for questions. So if you have questions throughout the presentation, feel free to chat them there. We have the other advisors. We have Audrey, Heather, and Myra to help me with those questions. And then I will be voicing those questions out to our presenters during the breaks that we have for questions. So yeah, those are my reminders for you all. Have a great time. And now I'm gonna have the department leadership. So we have here Jeffrey Boker, who is the EECS chair and the EE division chair. And we also have John Canny, who is the EECS associate chair and CS division chair, joining us today to talk to you more about the department. So welcome, John and Jeff, take it away.
Thank you, Andrea, and welcome to the students. It's a great pleasure to be able to make this presentation, and I wish I was doing it in person in front of a nice big room with all of you so I could see all of your eager, happy faces. But we have to make the best of the situation that we're in, and that'll be a lot of what we'll be experiencing in the coming semester. So if we all work together and give each other some space and accommodations, I think we'll be able to get through. So I'm glad you're here. I'm glad you decided to come. So let me start out by introducing my co-chair, John Canny. He's the CS Division Chair, Associate Chair of the department. We together work together to help keep things running smoothly. It's a very big department, as you'll find out. Lots of students and lots of faculty. And we'll tell you a little bit more about our identity as a joint EECS department with two different divisions of EE and CS. Let's go to the next slide. So, John, why don't you take over?
Yeah, thanks, Jeff. I also want to welcome everybody. We're excited that you decided to come to Berkeley. And it's a great school. It's a very large school, challenging to navigate. So we want to help you make it through and get the best out of the experience in your undergraduate program. Some of the people that you'll be speaking to, hopefully at some point, Jeff and I would like to talk to a lot of you if we can. We have lunches with student groups year-round. They're virtual lunches right now, but that's an important way for us to get feedback directly from students. Undergraduate associations, you've heard about them, the clubs that we have, that's an important part of student life and also an important part of feedback to the leadership. Moving on to the undergraduate leadership, those people right now are John DeNiro and Seth Sanders, respectively representing computer science and EE sides of the department. John, I'm sure a lot of you will know, if you don't already, well, very soon you'll know him from our large undergraduate courses. And Seth is not quite as visible, but still very dedicated to helping you out. And so, these are the folks that decide policy for the department, and also they can help you sometimes with some of the gnarlier questions, and they'll be online to help during this presentation. Okay, so back to Jeff for the agenda.
Just, mention you will get to meet John DeNiro sooner than that. He's the next speaker. So,
Yeah, that's what I was mentioning.
Okay, can we get the
coming
next
up.
slide,
Yeah.
Andrea? Oh, there we go. Okay, so this is the agenda for this session. I saw a question in the chat. What are we doing? This is it. So after a brief introduction and welcome from John and myself, we'll go into John DeNiro will take over, and he will give you a pretty detailed overview of the program, especially the lower division curriculum. There will be a break at that point for questions. The curriculum typically generates a fair number of questions, so John will take questions, and you can enter your questions in the chat, and the advising staff is going to help to organize the questions and present them to John at that time. After that, you'll learn more about advising. We have a big advising staff. They're terrific people. Many of them are participating. You just heard from Andrea, who's kind of our MC for the event today, but we also have a number of other of the advising staff on the call or on this meeting, and that are there. You can see some of them in the chat, and they just represent actually a portion of our advising staff. So we have a lot of resources out there that are available to help you get through, and you'll learn more about advising, which includes not just this terrific staff, but of course we have faculty advising as well, and you'll learn a little bit how that's going to work. You'll learn about computing resources, which are extensive in the department, and finally there'll be another wrap-up of question and answers. So let's go to the next slide, please. And this one's for John.
Yeah, thanks. So Berkeley's program, EECS program, is one of the relatively few integrated EECS programs in the country. Everybody learn the spectrum of technologies that comprise electrical engineering and computer science. So that's going to include some basic math and science, as well as the courses that help you specialize along one track or the other. Another important part of your experience here is working on team projects, working on pretty significant open-ended projects in many of our courses. And that's to help you develop skills at working with other people, and in a lot of cases, demonstrating leadership, knowing how to sort of deal with adversity sometimes, or challenges in projects. And those experiences are very important later in your careers. So Berkeley is one of the top programs in the country, which means that, you know, if you go into industry or if you go into academia, you're very often expected to take a leadership role in the projects that you work on. And the teamwork that you do at Berkeley is a good chance for you to stretch your legs and find your way, figure out how to work with other people and get the best out of them, and to sort of have your own vision of how things should evolve and to make that a reality. So that's an important part of the program here. Again, diversity is an important piece of that as well. Most workplaces are becoming much more diverse over time. And that's a strength at Berkeley, that we've worked very hard and established a lot of programs to try to improve diversity and the experience of a diverse population. Actually, next slide. This is a good time to segue into the next slide. There we go. So yeah, so our community is already quite diverse in many dimensions. It's not necessarily representative yet. We're still continuing to work on that. There are a number of challenges to do with history, also California's prohibition for state institutions on affirmative action, unfortunately. But anyway, we still work quite hard to make sure that everybody in our program at both undergraduate, graduate, staff and faculty feels included. And all of us need to work together to eliminate perspectives and actions, and even unintentional actions and language that make people feel excluded. So those are the principles that we hope all of you will follow. in your program here. We do a lot of specific outreach activities. A few of them are listed here. CS Kickstart is a program designed to sort of encourage people who are not oriented very much towards computing to experience and maybe sign up for the program. CS Mentors and CS Scholars are two very important programs for making sure that everybody succeeds in our program. And they're both a strong support structure for primarily for our intro courses, but also a chance for a lot of students to volunteer and help other students. These are really student-supported programs. And that's part of the culture at Berkeley is students helping, volunteering, and you know, giving back to the program and giving back to their community. So that's really what makes that work. We have an attractor course called Beauty and Joy of Computing, which is on campus, but we're trying to export it, or we are exporting it also to schools and many other campuses actually. And finally, transferring from community college is one of the main channels by which we can improve diversity. And so we have a specific program to facilitate and enhance successful transfers from outside, from two-year colleges. And finally, we're standing up a course on social justice and anti-racism specific to EECS. That'll be a mezzanine course, so both grads and undergrads. And we're debuting it next spring, and it'll be small the first time just because of resources, but we're hoping to scale that up fairly quickly over time. All right, so next slide. And back to Jeff.
Yeah. Okay, so I want to take a moment to talk a little bit about academic integrity. Academic integrity and ethical conduct are of utmost importance in the department, but of course across the campus. And we know that the EECS community is quite large, but we do hope and expect that you will get to know each other and form lasting and meaningful relationships in the field that will transcend your time here at Berkeley. You'll be making friends and connections here that will be with you for the rest of your career in many cases. And so one thing I wanted to bring up about academic integrity is that, you know, people struggle with making choices and decisions around academic integrity, but try to keep in mind that your peers are going to be your future colleagues for the rest of your career. And so we hope that that'll help motivate you to really act with the highest form of integrity so that you'll be remembered by your colleagues and connections who you may be forming companies with, you may be joining companies with, you may be socially engaging with these folks for a very long time to come. And this is the time to, you know, set a tone and an impression with them that you act with the highest form of integrity, that you act and follow the honor code that's written here on the screen, that you act with honesty, integrity, and respect for everyone. We know that you will be engaged in working on different projects in groups or separately, problem sets, lab reports, and so forth. And so the honor code and the right thing to do is to act with the highest degree of integrity, avoid plagiarism, unauthorized collaboration, or otherwise cheating or otherwise facilitating any kind of academic dishonesty. Now, in each course, every instructor will, at the outset, provide guidance for what kinds of collaborations are allowed and even encouraged, but what kinds of collaboration and so forth are out of bounds and in violation of the code. And so we hope that you will, act with the highest degree of honesty and integrity, follow the honor code, and be remembered as somebody who's honest and can be relied upon to do the right thing by your colleagues. Okay, next slide, please. I'm going to stick with this. John already mentioned of the fact that we are one of very few joint EECS departments in the country and in fact in the entire world. And we think that this is really a competitive strength. As you'll learn from the presentation to follow, our program has a set of 6 required what we call lower division courses, and those span all the entire field of EE and CS, from hardware to system analysis to computing, computers, software, and all the subfields that you can see indicated here on this slide. And our upper division program gives all of our majors the freedom to choose what kind of courses that you take within the major across this spectrum. You can take all EE-oriented upper division classes or all CS. Well, what we recommend is that you mix it up so that you have a good understanding of the entire field. Out in industry, what we know from talking to companies, that we have a lot of great relationships with companies, and you'll come to be able to participate in that as a Berkeley EECS student. We know that to be successful in industry today, even if you're a software developer, you know, the hardware is evolving so fast, and it's making a big impact on the kinds of software systems that we're using and developing today. And so it's good to have an understanding of that hardware. Similarly, for a hardware person who works on, you know, designing chips or even working on the design of individual transistors, it's really important to understand what's evolving in the very rapidly moving landscape of systems and software today. And so, yeah, even a transistor designer, it's important to know what's the latest machine learning kind of software that's being run, because it has a direct impact on the technology. The development of the hardware and the software technology is evolving together very rapidly these days. And you, in a very unique and have a special advantage being here at Berkeley EECS, where you have the opportunity to really learn about and participate across that spectrum. So please take advantage of that, and we hope that you will, and we know that when you come out of this program, you'll be recognized as somebody special, and with a leg up over graduates from many other ECE or CS programs that are out there. And finally, next slide. Of the details on that, and
let me go forward, Anvia. Yeah, there we go. So there's the lower division, and as Jeff mentioned, that spans a spectrum from sort of pure computer science on the left in yellow through hardware and some of the mathematics of EECS in CS70, and then the sort of core EE lower division courses, which cover signals and systems. And lower division, that's your first couple of years in the program, ideally, although, you know, you've got flexibility in when exactly you take the courses. And then next slide. So after that broad core that everybody takes, there's a set of options for your upper division work, your final 2 years of the program. And you can see, again, it's going in a spectrum from computer science, pure computer science on the left, through to physical electronics on the far right. And then in the middle, you have topics like networking, architecture, security, which span EE and CS. But the exact form of your program is up to you. And we don't at this time distinguish CS grads from EE grads in the degree that you receive. You're just an EECS graduate. So in addition, maybe next slide. It's actually just an overlay. Yeah, so in addition, there are a variety of other requirements that are important for you to be a well-rounded student. The humanities and social science requirement is College of Engineering wide, and that's 6 courses. It's a non-trivial program. It involves a reading and composition, some American cultures requirements, but a lot of elements that will hopefully help you to become a well-rounded intellectual. Will help you hopefully work with other people and understand them better. And in addition to the humanities social science requirement, there's an ethics requirement, which is also a COE requirement. And for the EECS degree, also there's requirements of math and physics and some other physical sciences. So again, the goal is to give you a pretty broad education in addition to the specialized EECS courses. And we think that's the most valuable way to prepare you for the gamut of your career. That's probably going to start off very technical at the beginning, but likely for most of you will move into more administrative and leadership roles later on. Okay, so John DeNiro is going to take it from here, and I'll sign off and I'll take a look at the chat to see if any of you have questions. Okay.
Take it away, John. John DeNiro, you'll get to see him, many of you in 61A in the fall, as well as his role is the Vice Chair for Undergrad Matters. He's one of our leading lights in the department, and I'm happy to now introduce him and turn it over to John.
Yeah, thanks a lot, Jeff and John. I'm John. I'm very excited to talk to you today. The people that come through the undergraduate program here are just so delightful, and I look forward to meeting you because I suspect you are very delightful as well. It's the thing that makes me love teaching here is working with the students, especially the undergraduate students. That's where I spend most of my time, just because that's what I enjoy the most. And why do I do it at Berkeley? Well, Berkeley is my favorite place in the world. It's a wonderful university. I've had just an amazing set of experiences here. And it's not just because it's in a nice spot next to the bay, which, you know, eventually you'll get to experience, but also and mostly because of all the people here, the faculty, the staff, the students, the culture. Yeah, it's just a very special and unique place that has kept me coming back year after year and having fun every time. So I really look forward to getting to know you. I'm going to talk a little bit about the lower division, sort of what you're getting into for the next year or two. And Andrea, you can go to the next slide. And I hope you ask questions along the way, because now's a good chance to get oriented. Like, you're going to take these classes, so I don't really need to tell you what's in the classes. You will take the classes. But it's helpful to have an overview of why all these classes are there, how they fit together. Your goal should be to learn what you're supposed to learn in these classes, but also figure out what's really exciting to you. Because after you work your way through these classes, you're going to have to pick upper division electives. And these classes give you exposure to lots of different areas, so that can be helpful guidance. What do you want to do research in? What courses do you want to take? What do you want to focus in? What are you excited about? Hopefully after you take these 6 courses, you'll have some idea. That's usually how it works. And if you have interest now, like, that's wonderful too. You know, don't hold back pursuing your particular interests just because you're taking more general courses, but also make sure that you learn what's in the more general courses. I think the foundation that we provide really is helpful in understanding pretty much any focused area within electrical engineering and computer science. And where does it all begin? Well, it begins with CS 61A and EECS 16A. Oftentimes students will take these together. 61A is a course about programming and program structures. A lot of students have programmed before, not all. It's fine if you haven't. It's typical if you have. And the truth is that there's lots of different ways of thinking about programming. One is that you want to be able to build particular kind of small things. That's where usually people start out. But another is that you want to set yourself up to be able to build anything, including the large distributed systems like operating systems and major services like Facebook. And you have to have a kind of a different way of thinking about programs if you want to be able to scale up to really ambitious projects. And we don't build really big projects in the first course, but we do try to get you in the process of problem solving that will allow you to solve really big problems, so that when you come out of the lower division, you can't just build like a particular thing or know some particular programming language, but instead you're set up to be able to build pretty much anything that you want. So this course is unusual relative to what's taught at other universities and in boot camps and stuff like that, in that it focuses more on how to organize programs and how to manage the complexity of large programs, rather than just like learning the features of a particular programming language. We do that too. It is really nice side effect of this course that you learn how to program in Python really well, and that you understand why the programming language is the way it is, and all that you can do with it and its flexibility. So absolutely, we want people to become very strong programmers in this course. But at the same time, we want to make sure that the knowledge you're building is generalizable to other programming languages, other things you might want to get done. And so it's not so specific about solving particular problems, but instead is about the foundational ideas that have stood the test of time for the last 40 or 50 years as things you really need to know in order to build ambitious software. So we talk about what are called programming paradigms. These are conceptual frameworks that people use in order to organize large programs, and they also influence the design of programming languages. So we'll talk about functional programming, object-oriented programming, declarative programming. If you know what these things are, that's fine. You'll still learn something new. If you don't know what these things are, that's also fine. That's why you're taking the class. The point of taking a class is not to just show off what you already know, but to learn something new. Otherwise, you wouldn't need to take the class. So yeah, so if I say things, feel free to ask about them. You can ask questions in the chat, and I'll pause in a little bit and answer whatever questions have come up. But definitely don't panic if you see something that you don't know what it is. You could ask or you could not ask, and you'll learn either way, because when you take the course, we'll talk about what all these things mean. Then some of you might feel like you have taken an intro CS course before. You've taken APCS or something like that. And so you're wondering why you would take this course. I'll talk about that in a little bit. But what we found is that almost everybody who comes to our program, regardless of the amount of prior experience, learns something from these intro courses, often quite a bit. And it is possible, if you've really seen it all, to move ahead. But for the most part, you really want to just build a solid foundation of skills and understanding before you start leaping into more advanced stuff, because then you can contribute more to the more advanced stuff. So almost all students actually take all 6 of these courses. You can go to the next slide. So 61A and 61B almost always taken in order. They don't have to be, but they usually are. And so CS61B is a second course that's about data structures and algorithms. So these are like particular inventions that computer scientists have come up with over time that are the right way to solve problems that show up over and over again. Like when you are building a program and it's time to sort a list, there's really kind of several ways to do it that have already been discovered. You rarely need to invent your own algorithm for sorting a list. Instead, you should study all the ones that have been invented in the past and learn about their properties. Now, when you're writing a program, there's often things that haven't been solved before. That's, I think, where 61A starts, is talking about how to solve problems generally if they don't fit nicely into an existing algorithm that someone else has invented. And then in 61B, you learn about all the different algorithms that people have invented for particular problems that show up time and time again, which is really foundational stuff. It's a course with just a lot of content, because there's a lot that's been discovered over time, and it turns out to be foundational to building large pieces of software. And so the course covers a lot of ground, which is great. That means you know a lot coming out of 61A and 61B. If you try to take 61B before you kind of are comfortable with the 61A concepts, then you can often have a hard time and not get as much out of the course. Like if you take courses and you don't really understand what was in the courses, it's not nearly as valuable as if you really learn everything there is in the course that you're taking. So that's why I recommend taking them in order, 61A then 61B. But I'd say people who have taken external coursework often have learned a lot of the content that's in 61B. And so it's more often that students will pass out of this course based on prior experience than 61A. Well, most of you will take it. And what will you learn? Well, fundamentals of software engineering like design and development. You'll learn lots of different data structures, their purposes, their properties, lots of different algorithms, when to apply them and how, and be able to predict how they'll behave when you do apply them. And what differentiates this from many other data structures and algorithms courses out there is the size of the projects. At Berkeley, we really want you to be able to build large pieces of software, not just small toy pieces of software. And so, yeah, so I think something that's unique about this course is the scale of the projects that you build, even in a lower division course. Okay, let's march ahead, unless there are questions that I should answer now. I'll let Andrea let me know.
Is a question. Do you want to go over that now, or should we wait
Sure.
for time? Yeah.
Yeah, why not?
The question is, are there specific tracks or categories of classes that we can use as a guide for specific interests?
Yeah, great question. So the way that the research is organized in this department is around particular fields or sub areas of computer science. There's a group that works on, and electrical engineering. So there's a group that works on networking, and a group that works on information theory, and a group that works on artificial intelligence, etc. For basically every research group, there is an upper division course that tells you what you need to know in order to really understand what that's about and kind of take your first steps toward doing something interesting in that area. So those courses all have prerequisite chains. So if you want to get into machine learning, then you'd find the machine learning course. Well, actually, there's two, which is fine. So there's the CS 189 and there's CS 182, and oftentimes people take both. But check out both of the courses in the course catalog and look at their prerequisites. And if you're not sure how to interpret their prerequisites, or you've heard that oh, maybe there's other courses that would be helpful, feel free to ask on the EECS 101 Piazza, where there's lots of discussion about what you should take before you take some course. There's also a guide put together by a student group called HKN, which you'll find if you ask about it on EECS 101. So there is a lot of guidance about when to take a particular upper division course and what to take before and stuff like that. And you should learn about that. But your first step is just to decide which upper division courses look interesting. And then you can kind of work back to oh, if I want to specialize in this, what else should I take? And yeah, so once you kind of pick which course you want to focus in, that's how you'd ramp up into that area of electrical engineering or computer science. And yeah, I think that's the best guide. Okay, thanks for the question. And we can go to the next slide. So CS61C is really, I'd say, at the intersection of electrical engineering and computer science, in that it's about how computers actually work. So it's a machine structures course, great ideas in computer architecture, how computers are organized in order to execute the programs that you've learned how to write in 61A and 61B. And yeah, I think this topic is just more interesting when you know how to write large programs and you're wondering how do they actually execute, and understanding how computers actually do what you program them to do is very helpful in writing programs, and also is an interesting field in itself, that like, some people have to figure out how to make computer architecture even better. And you know, improving how computers work generally has a massive benefit to all sorts of fields of computer science that then have their programs run faster or more efficiently or whatever. So this is a course about parallelism, low-level programming, kind of how you give instructions to chips directly, how memory is managed in a computer, and also a nice introduction to how operating systems work and how computers are organized and why. And there are, you know, there are students who absolutely love this course and it's their favorite course because this is the part of EECS that they're most excited about. And then there are some that are excited about something else. They really care about the electrical engineering and this is a little bit too high level, or they really care about the software and this is a little bit too low level. But in either case, it's really worth knowing this so that you can be more effective at whatever part of EECS you decide to pursue later. Okay, next. So Computer Science 70 is a math course. It also spans electrical engineering and computer science, in that it's mathematics that applies to both these disciplines, which, you know, are really kind of one discipline with a lot of different sub areas and a lot of stuff in the intersection. But they're also distinct in some ways. So it's a kind of math course that's different than what you might have been used to, and then it's very much focused on proving things. So probably you took a geometry course and you wrote a lot of proofs there. Similar story here, except for now you're proving about the behavior of some program or some mathematical procedure. And why do you need to learn how to prove stuff? Well, when you have complex systems, hardware systems or software systems, the only way you know the whole thing works is if you know all the individual components really do what they're supposed to do. If anything's misbehaving, then probably the whole thing is going to crash. And proof-based approaches are a great way in order to kind of guarantee that some particular part of some large system is actually going to do what it's supposed to do. So it's an approach to thinking that you just have to learn if you want to move forward in EECS. And it's also just full of wonderful mathematical discoveries. So algorithms for a variety of different problems that have come up over the years, spanning, you know, cryptography, but also like organizing information, running things quickly. There's a large section on probability theory so that you can understand how to reason about things where you don't know the answer. You only know a probability distribution over what might happen, but you can still draw all sorts of interesting and robust conclusions. And this just shows up across basically every part of computer science and electrical engineering these days. So you got to learn it. And then there's this interesting line of reasoning about what can be computed and what can't. And could you prove that something can't be computed? Wow, that would be pretty cool, because then you would save your time not trying to compute that thing that is impossible to compute. So, you know, not all electrical engineering involves just working on devices. Not all computer science involves just writing programs. A lot of it involves thinking through the problems you want to solve on, you know, pen and paper. And, you know, that's the math part of it. And this is the course where you get started on that. Okay, next. So the next two courses are a series. EECS 16A and 16B are a mixture of learning about devices and manipulating information in the abstract, which is, you know, involves mathematics. So you're going to learn a branch of mathematics called linear algebra while taking these courses. You learn so much linear algebra in these courses that you don't actually need to take a separate linear algebra course from the mathematics department. Some people do anyway, and you're welcome to. But the mathematics you need in order to reason about information is in these courses. And at the same time, like math it can be interesting if you have applications for it, and the applications are around designing devices that actually interface with the world. So here's a few listed out. Some imaging systems, so like how does a touchscreen work to detect your touch? How do displays work? How does wireless communication work? All of these involve some amount of like manipulating information, and then also building devices. You learn about circuits and stuff like that. So this is the core that sets you up to think about not only the information manipulation that happens across EECS, including in artificial intelligence and data science and stuff like that, but also in designing devices. And then it gives you some practical experience of building devices and the concerns that come along with that, and understanding what circuits are, how to process signals, things like that. So that's 16A. You can move on. 16B continues these themes. You learn more aspects of linear algebra, including some really important techniques that are used across not just EECS but lots of other disciplines. And then it's got some great applications: brain-machine interfaces, digital signal processing, how radios work, and some part about robotic control, which I think is pretty cool. So yeah, I guess there's some variability in when people take these courses and in what order. I think a very common approach is to take 16A and 61A together in your first semester, and 61B and 16B together in your second semester, and then take 61C and 70 in your third semester. Then you're done with them all, and you're taking 2 at a time. It is possible to take 3 at a time, but I don't recommend it. It's also possible to take 1 at a time, and most people take 2. So if you're deciding to take only 1, you should probably check with an advisor and make sure you have a plan about that. And yeah, you get more out of things when you take them in the order that they were designed. So there are like nice relationships between 16A and 61A, for example, that happen during the course. And so if you take them together, then you might see some of those connections. They both use a little bit of the Python programming language, and that could be helpful. So yeah, so that's the general guidance. People pick different schedules for various reasons. Like if you have some particular upper division course that you want to take as soon as possible, then you might rearrange your schedule a little bit in order to take that sooner. But don't take it so soon that you don't know the background. Otherwise, like, you're not going to learn that much from the course. So make sure you're really solid on what you're supposed to know before you go into an upper division course, before you take it. Okay, I'm going to pause there for a second, see if Andrea has any other questions for me. Otherwise, we can move on.
Yes, there's questions. So the first one says, is it better to have a focus on just EE or CS after finishing the lower division courses, or should I take classes from both paths?
Oh, interesting question. A lot of students take them from both. If you look at the most recent faculty that have joined the department, a lot of them are working at the intersection of electrical engineering and computer science. They're doing artificial intelligence applied to robotics, and you kind of need to know both, or signal processing and data science related to microscopes and imaging, and you kind of need to know both. So there's absolutely nothing wrong with taking a mix. That's why we've set up this program, is in order to enable that. But that said, some people find that the computer science or the electrical engineering side is really where their interests lie. And so once you've sampled everything, you've taken the whole lower division, then it's okay to focus on one of these halves of the whole.
So there's another one that you touch on a little bit. So a student asked, should we take CS 61C after 61B and 16B, or can we take it after just CS 61B?
Good question. 61C depends mostly on 61C depends mostly on 61B. So I would say, actually, like, in terms of natural chains, it's CS70 that follows most naturally from 16A and 16B. So if you want to, like, really understand what's going on in 70, it can't hurt to have the additional mathematical maturity that comes from taking 16A and 16B, which are kind of hybrid math courses plus lab-based electrical engineering courses. And 61C doesn't rely as much on the content of 16B. It's more self-contained, I would say.
That's all the questions we have for now.
Okay, cool. And then we can go on to the next slide. Lower division is not easy. You might have the mindset that like doing anything introductory is a waste of your time and you should just figure out how to get it out of the way as fast as possible so that you can do the real stuff, which is the upper division. Or maybe you think that only the real stuff happens in grad school or after grad school. I don't know what you think, but we really try to design our courses so that they're all valuable to the students that we get. And the students that we get, well, you know, you're not typical in any way. Every student is different, but we do have a sense of the kind of broad distribution of backgrounds that students have, and we try to tailor these courses to be valuable to you. So the thing is that Berkeley attracts some really bright students. So as a result, we've made these courses quite challenging so that they actually, you know, help you learn something that you didn't already know. The consequence of challenging courses, other than that you might learn a lot, is that they can be frustrating. At times, they could even be demoralizing. Like you might think, oh, you know, I really spent hours on this and I didn't solve all the problems. Like, what's wrong with me? Well, nothing is wrong with you. There are always problems out there that you won't be able to solve. That's true even if you become a professor someday. There are problems that you wish you could solve that you can't solve. I mean, that's just how life is. So, you know, if you find these courses challenging, you should not think that this is a reflection on you not being, like you shouldn't be here or something like that. That is really not true. Absolutely, you should be here. And absolutely, you're going to find some things to be really hard. And that's okay. That's pushing through that and mastering the things that you previously couldn't do is why you go to college, especially a great university like this one. Is going to push you quite a bit in order to do things that maybe aren't comfortable, maybe aren't easy, but you can learn how to do them, and then you can do stuff that you couldn't do before, and that's the whole point of education. So, you know, what makes these challenging is actually different for every course. So if you ask students like, which is your hardest course or which is your hardest project, you get a large variety of answers. And why is that? Like, shouldn't there be some natural order? Well, no, because they're hard for different reasons. So 61A tends to be kind of conceptual difficulties, kind of training your brain to work in a different way if you haven't solved a lot of computing problems before. Most people, by the end of 61A, have figured out how to do that. And so 61B tends to be challenging because of the scale of the assignments. Like, it has really interesting conceptual stuff, but you've sort of learned how to learn in 61A. And so people get better and better at kind of learning new topics and understanding things they didn't understand before. But then we throw you this curveball of just really large assignments that you have to figure out how to organize your own work in a way that maybe it hadn't before. And 61C is different still. It's about learning a lot of detail about how computers are architected, and that can feel a little bit different than anything you've done before. 16A, 16B, and 70 really are designed to ramp you up in terms of your ability to perform mathematical reasoning. So to understand the structure of proofs and kind of know what you know and know what you don't know. And that is not something that is like a natural human ability. It's something that you have to learn and you have to practice. And all of these courses have that characteristic now to different degrees. So 70 expects a higher sophistication of mathematical reasoning than 16A because you're supposed to take them in this order. We do assign a lot of work because a lot of these things you can't learn unless you practice. And we do move pretty fast because, yeah, the focused human mind, especially of folks that come to Berkeley, can absorb a lot and can advance quickly. And so we want to kind of set you a pace where you can learn as much as you can and get ready to go do your best work when you enter the upper division. Next slide. So I guess the takeaway from this this point that the courses are hard is that you don't really want to take them all at once. Like, you'll hear that maybe once upon a time there was a student that took 61A and 61B and 61C all in their first semester, and I guess no one's asked. Maybe this is true, maybe this is not. I do know the answer, but extraordinarily rare. And some people have learned things before they come to Berkeley that others haven't, and that's just life. But the advice I'm giving you is generally applicable, that you really just want to take a couple courses at once, not more than 2. And if the 2 that you're going to take are going to take up a lot of your time, then make sure you adjust the rest of your schedule so that things are manageable. And what about skipping these courses? Well, if you've already taken similar courses, please do talk to an advisor about your background, your goals. We do have a mechanism for people to skip the whole course for any one of these, or to skip most of the course. This point about bridge courses that are labeled 47 is that they basically just take some part of an existing course and have you do only that. So for 61A, there's a unit from weeks 10 to 13 that is replicated basically in no other courses. And so if you've seen everything else in the course except for weeks 10 through 13, then it's possible to take what's called 47A, which is a course that's just those 4 weeks. Now, you have to kind of do it all on your own, at your own pace, and turn in the assignments. So this isn't generally a good idea for most people. It's not like an optimal learning environment. But for students who have really seen a lot of this material before, it can help you move past the parts that might be redundant while still learning the parts that are unique to Berkeley. So you can email me directly about that. I'm easy to find, DeNiro@berkeley.edu. Maybe I'll put that in the chat really quick. But it's usually more productive to email the professors, the advisors, because they know a lot more than I do, and about how Berkeley works, and also they tend to be more responsive. But either way, like, if you think you're signed up for classes that are the wrong set of classes, you might as well ask and figure out if that's true or not. But for the vast majority of students, we don't recommend these, or might not even allow you to take these, because they're really wrong, and we want to make sure that you don't end up in the upper division without the foundation you need in order to succeed there. Okay. Any questions, Andrea?
There are a couple questions. Let's see. A student asked, can we take CS61C and CS70 concurrently once we take the other courses? This is in terms of the course order synergy you were talking about.
Yeah, it's quite common to take 61C and 70 together, and they don't relate that much to each other, but they're complementary in the following way. In one course, you're solving math classes, and in another course, you're building projects. You're solving math problems, and in the other course, you're building projects. And so you want to have projects from 2 courses at the same time, because you're only taking one kind of project-based course. So that balance is actually something that students really appreciate, is having sort of different characteristics of the 2 courses that they're taking at the same time, so that they have some variety in their life.
Thank you. Then the next question says, any advice on how to choose between the vast upper division choices?
Yeah, good question. I mean, I think you'll know a lot more once you take some lower division courses. You can always ask your professors, your teaching assistants, people you run into. I guess you don't run into them in a virtual environment. but there's lots of ways to connect with other students, and especially in classes. So there's lots of teaching assistants, and they like talking about their experiences, or tutors or people that are part of undergraduate groups that do like advising and tutoring kind of informally. So if you have specific questions about like, oh, these few classes look interesting, but I don't really know what they're about, then you just have to have that conversation with somebody. And you don't have to do it today because you don't have to decide your whole schedule right now. But don't forget that eventually you'll have to pick classes, and so it's nice to learn about them when you can. And so if you do end up talking to a student who's in the upper division, upper class student, asking them which upper division courses they picked and why could be a very useful way to have a kind of meaningful conversation with them, because they probably once were in a position like you where they had no idea which ones they wanted to take or even what the names of the courses meant, and they figured it out. And usually you figure most of this out by taking the lower division courses, but also talk to people.
All right, we have quite a few questions. We keep going with questions, or do you want to take them during the break?
Yeah, let's have questions.
Okay, cool. So a student asked, does taking CS61B and CS61C concurrently make sense?
People do it. It is 2 project-heavy courses at the same time. So, and we're not always able to make sure that the projects don't overlap. So it can be a pretty intense semester if you do that, but people do it somewhat regularly. I would not say it's like the most typical path, but it's something that happens. I think the most common variant on the schedule that I mentioned, which is 61A, 16A, next semester you do 61B, 16B, and then you do 61C and 70. Probably the most common variant is to do 61A, 16A, and then the next semester do 61B and 70. And that's kind of breaks the natural sequence of 16A, 16B, 70. But, it's been done many times before. And still, you're basically taking one programming-oriented course and one mathematical course at the same time, as opposed to 2 kind of programming project-based courses at once. But for any given variant that you can imagine, probably someone has tried it, and probably someone has succeeded at it. But asking an advisor is a good way to understand whether this is a good idea. So I would say, in particular, taking 61B and C at the same time is not necessarily a terrible idea, but will involve some weeks that are tough because you're doing projects in both courses at once.
Awesome. Similarly, we have another question that says, are we able to take CS70 alongside EECS 16B?
Yeah, actually that is not too unusual. Take 70 and 16B at the same time. They're both, math heavy courses, but they are different branches of mathematics. And so, the idea of writing a proof is not about a particular branch of mathematics. It crosses both, like all branches of mathematics, and so it's relevant to both of these courses. So you might have some nice synergies there. And so it's not a crazy thing to do at all.
Thank you. Now we have a question from a transfer student. They ask, for transfers, what do you have to say if we take CS61A, EECS 16A, and CS70 on our first semester, if I have background in linear and C++?
Yeah, good question. So it can work. Transfer students tend to know more, right? You're transfer students because you've done a couple years of college level coursework already, and that can allow you to take a 3rd course at once. And since you only have so much time here, it's a more natural thing to do for transfer students. That particular combination, I guess, it's going to be busy. Like any 3-course combination is going to be busy, but it doesn't sound problematic in particular.
All right. This is a question for you. It says, well, all the questions are for you, but specifically for you, given your lectures. Will we be able to interact with you during the online lectures, or is that reserved for discussion sessions?
Oh, well, here's what I'm going to do is, well, so if you're not careful, you might get a history lesson. So that's going to happen in this case. So I've been teaching 61A for some time. If you're in it, great. I can't wait to work with you. When I teach it, when we have access to campus, everyone comes to the first lecture, and by lecture 3, most people have already switched to watching videos. They're not watching videos of the live lecture. They're watching videos that I made in a studio where I cover the content just like I would in lecture, except that I like edit out all the ums and the places where I screw up and stuff like that. And so they're just like a nice, compact, straightforward way of hearing me explain the lecture material. So in a normal semester where we didn't have a pandemic, most people would be watching video lectures anyway. This semester, that's going to be the primary offering, since it's like by far the most popular way of watching anyway. And I think it does work better than some big synchronous Zoom session or like what we're doing here. But for every lecture, I'm going to have a live question answer period after I post the videos. So I'll post them the night before. If you want to watch them the night before and then talk to me about what was in the lecture, I'm going to hold a live Q&A session where you can just come talk to me about what happened in lecture. Now, these are not general office hours. I'm not going to talk about like some random exam problem or something like that. I'm going to just go over lecture examples. If you don't have questions directly, I might kind of reteach some little part that I think is critical to get questions to pop up. But yeah, so we will have a live Q&A session every Monday, Wednesday, Friday morning. And if you want to kind of talk to me and ask me questions directly, that's what that's for.
Okay, awesome. We have 2 questions, and let's just do these 2 and then move on, and then when we get the questions again later.
Yep.
They ask, if we take EECS 16A, is it worth taking Math 54, linear algebra and differential equations, or is there no points since 16A teaches you plenty of linear algebra?
Yeah, good question. So for most students, you don't need to take Math 54 if you've taken 16A and 16B. 16A itself doesn't cover all the linear algebra that's in 54, but the combination of the whole series does cover pretty much every linear algebra topic in Math 54. It does not cover differential equations, which is like a totally separate branch of mathematics, sort of related to linear algebra. It's only in Math 54. So if you want to learn about that, take Math 54. Also, you know, linear algebra is really important. And just because you take a class doesn't mean you learned everything that you could possibly learn about a topic. So some people do take Math 54 in addition, because that means they kind of hear a different professor, a different point of view, even though there's a lot of redundancy, like all the topics are the same and all the techniques are the same. Some people find that going through it twice really improves their problem solving ability and their ability to use linear algebra practically. So I'm not going to say that for every student you should never take Math 54. Some people do, and they get some benefit out of it. And it's better that you learn linear algebra, even if it means taking 2 classes, than that you don't learn it. So you might consider taking Math 54. But in general, I don't recommend it because the content is covered in 16A and 16B together.
Okay, also related to linear algebra, this next question. Do we have to have linear algebra knowledge before going into EECS 16A if we're only in Math 1B this semester and planning to take EECS 16A and Math 53 together next semester?
Good question. I would say you do not need any linear algebra knowledge. You don't even need to know what linear algebra is in order to take EECS 16A. It is taught in the course. And we can jump to the next slide if we're going to pause questions for a little bit. Well, strategies for success. Yeah, so the chairs and the advisors and I kind of all collaborated on writing down a list of things that generally apply, maybe not perfectly to everybody, but something to think about. Don't overload yourself. If you take a full class schedule and are searching for a research opportunity and joining a student club and have a part-time job, you know, it's very hard to get what you should get out of your courses if you don't make time for them, and you can make yourself miserable. So 2 reasons not to overload yourself is just so that you can have like a pleasant life, but also so that you have the extra capacity to dive deeper into something you see in a course, instead of just doing the bare minimum in order to like get the grade that you want. You know, this is a unique opportunity to be part of this learning community. You might as well take advantage of it. And that means, you know, don't just minimize the amount of time it takes to get a course and check it off as like some like requirement you had to fulfill. But you might as well take it seriously and try to advance your own abilities as much as possible and your own knowledge as much as possible by taking the course. And usually the trick there is to take fewer courses rather than more, and really get the most out of each one. Don't fall behind. Don't do anything later than the earliest possible time that you could do it. So when a homework is released, that's when you should try it. Now, it's fine if you don't finish it the day that it's released. You don't need to finish it until, you know, it's due. But if you don't watch a lecture because you know it's recorded and you can always watch it tomorrow, it's very easy to fall behind. If you don't look at a homework because it's not due till next week and, you know, you'll just deal with it later, it's very easy to fall behind. So the students that are most successful tend to be proactive about just doing stuff when they can. You know, you don't have to do everything early, but you also should do things kind of when you're supposed to do them as opposed to delaying, because that can snowball, and then all of a sudden you have, you know, like 2 weeks worth of lecture material to watch and the exam is 2 days away, and so you know, flip it all to double speed and you hope you can learn it all, but it just doesn't work. So it's much better to just like keep up with all of your courses. When you have questions, ask them. Do it now. Finding academic teammates and taking classes together is a really good strategy. Now, there's some things about online education that work pretty well, like listening to a lecture isn't that much different whether you're on campus or you're off, because people just watch the videos anyway. Getting to know other classmates and collaborating with them is certainly going to be more challenging, so I encourage you to try anyway. And you know, put yourself out there, even though it's not the most natural thing to do in an online semester. At least in my course, and probably in other courses, we're going to try really hard to facilitate students getting to know other students so that you have a chance to form groups later that you can take classes with later. Now, like, I actually thought about this a little bit, like what happened to me in college. And I have 5 really good friends from college that I still keep in touch with. And I did not make them all my first year. 2 of them I met freshman year, and then one my sophomore year, one my junior year, and one my senior year. And yeah, she was the best friend of all, and now she's my wife. So yeah, it's not like not being in person for your first year means that you're never going to know anybody at all. But one of the great things about taking college courses is getting to know other college students and learning to work with them. So, you know, try to make that happen. If it doesn't happen this semester because the pandemic is making everyone's life a little bit harder, just accept that and don't stress about it too much. Like, you know, college is long and you have plenty of time to get to know people. But if you can make progress, you know, try it out. You know, if there's some system that's part of a course that lets you like work with another student over Zoom, you know, do it. Even if it doesn't seem like the fastest way to get something done and it's like a little bit awkward, just do it anyway, because then you can start to get to know people, and you never know. One of them might turn out to be a good one. Wow, and surprisingly a lot to say about that. Let's see where I was. So making use of course resources. Yeah, I'd say that courses here are different than non-college courses. In high school, you had one teacher and you know, they told you what to do and you showed up to class and you kind of did what you were supposed to do, and that was that. Here, things are much more flexible. So we ask more of students, but we provide resources for students that are finding it difficult. And that means you have to decide which optional resources you take advantage of. If you're stuck on a problem because it's a hard problem, that's fine, but it's going to be up to you to reach out and get help. And there's going to be lots of mechanisms that are part of each course in order to do that. There's going to be ways in 61A to sign up for appointments with a tutor. There's going to be weekly tutorials. There's going to be ways for you to group up with other students. There's going to be ways for lots of students to get together and have like one big collaborative session. It's going to be all kinds of stuff. But if you don't participate in any of it, well, then you won't benefit from any of it. So please try to make use of course resources. And if you don't know how to get help, then just ask. We have a course, Education 98, Strategies for Success, which basically talks about how to navigate this place and get the most out of college, something to consider. And the last one is to help each other out. You know, I think the world is large, and most people don't have the opportunity to go to Berkeley. It's almost never productive to think about, oh, I want to be the best at Berkeley. It's much more productive to think about, oh, I want to learn as much as possible and to benefit myself the most. And also, I'd like everyone from Berkeley to be learning a lot, because I'll know these people and we'll go out and just like run the world together. And that's what's happened, you know, year after year, is that great people come to Berkeley, they learn a lot, so they become even more effective, more knowledgeable, more skilled, and they know each other, and then they go out in the world and you know, work together, build great things together, and so you see like big groups of Berkeley EECS students, you know, and in the leadership and key roles in lots of different companies and organizations. So if you get used to helping each other out and making sure that you all succeed, then this happens even better. You know, we're not into ranking students. We don't really care about whether you're the best in the class or 12th best in the class or 287th best in the class. This doesn't matter. What does matter is that you're learning, like, time at Berkeley is productive in terms of you like getting better at whatever you want to do and learning about whatever you want to learn about, and that you build relationships so that you can solve problems that are so large you couldn't do them all yourself. And in EECS, most problems are so big that one person doesn't solve them. It's a collaborative effort. So, so if you don't get used to helping each other out, then you won't be as effective at it in the future. So, I'll say this again in the first lecture of 61A if you take that, but you're not all taking it, so I'll say it now. Like, if someone doesn't understand something yet, you shouldn't give them a hard time about it. You should just help them understand that thing. And actually, you'll be learning too. If you know something and they don't, one of the best ways to really learn it and remember it is to teach somebody else. So, you know, think about this as a community of people that all benefit when you work together. That's really how it is. You know, your individual competitions with other people at Berkeley tend to matter much less than whether you've all like become good at something. Next slide. Internships can be a valuable part of your education. We would like to help make that happen. You really do not need to rush into these. Most people don't do an internship after their first year. You can. If you want an internship after your first year, you often have to apply to lots and lots and lots of places. And that's fine, but it does take a lot of time. But there's lots of other stuff you could do in the summer after your first year, like take classes or help teach classes or relax. Relax. Or you can do an internship, but mostly internships happen after your sophomore, junior year. After your first year as a transfer student is very typical too. We'd like to help you out. We won't tell you what internships are right for you. Mostly we just help connect companies with students. And not just companies, but they're like government organizations and nonprofits and stuff like that that want you to be interns. And we have an intern fair coming up Wednesday and Thursday, September 9th and 10th. Research. I don't think research is for everybody. So research is trying to discover new knowledge. And there's an awful lot of interesting stuff you can do with the knowledge that's already been discovered. So if you want to discover new knowledge, great. I would encourage you to do so. That happens a lot at Berkeley. We're a preeminent research institution as a university. And also the EECS department is really top of the field in many areas. Certainly one of the top programs in the United States for electrical engineering and computer science. So if you want to get involved in research, it's everywhere here, and you can. This says typically for junior and senior year. That's because you can't really be helpful in research, like really helpful, like discovering new knowledge, unless you know the knowledge that's already out there. So you can get involved in a research group earlier on, but it tends to be less fulfilling work than what you'll do in your late stages, in your junior and senior year, after you've taken the corresponding upper division course, and now you know enough about networking to like tackle a new problem. Research is really important if you want to go to graduate school. It's relevant for industry as well. There are industry groups, that means groups within companies that are trying to discover new knowledge. They're doing real research, and you might be interested in that. But there's also lots of really interesting work and hard problems to solve that aren't really research. They're just like figuring out how to use the tools we've already discovered in order to do something new. So, so most of industry is not research, and that's fine. It's still pretty cool and pretty interesting. But if you're interested in research, we have a panel coming up on September 29th. And yeah, it's wonderful to try out research and get involved in it. But don't feel like you have to do it tomorrow, because even if you do find a freshman research experience, it's usually not as exciting as your senior or junior research experience. So, I don't want to discourage you if you're excited about research or if you've done it before. Feel free to get involved now. But most of the interesting opportunities come after you've taken the relevant coursework. And it's usually not the best way to learn about a field is to do research in the field. The best way is to take the class about that field and then do the research afterwards. Next slide. Well, questions?
Right, let's see. We're gonna have one question next, and then we'll save the rest for the very end since we want to get through the presentation.
Okay.
So it says, is there anything you would suggest doing differently because courses are online this semester?
Yeah, I would suggest really structuring your time. The biggest risk with online courses is that you'll fall behind because everything's recorded and you don't really have to maybe show up or whatever, or maybe you're in a different time zone. Don't fall behind. Tell yourself this every morning. And the way you don't fall behind is to, make a schedule for your day. You're like, oh, I'm gonna do this for these 2 hours. I'm gonna do this for these 2 hours. I'm gonna do this. Oh, knocked out my glasses. That's great. Yeah, I think that's the biggest thing. The second biggest thing is try something to get to know other students. Even if it's awkward, stick at it and stick with it for a while. But really don't fall behind. All right, well, it was a pleasure to talk to you. And I think I get to hand it off now.
Yes, but stick around in case that there's questions at the end for you, yeah?
Okay, I'm gonna disappear, but I'll still be here and I'll come back at that.
Awesome, thank you. Are you doing the advising and support as well?
Oh, I guess I am.
Yes. Awesome.
I love to talk about advising and support because our advising team is so amazing. You can go to the next slide. Oh, I thought there was a picture of them all. But anyway, you'll meet them all. The advisors, they really care. They really understand this university and how to navigate it. They talk to the faculty a lot. I talk to them a lot. We come up with policies together. We really try to come up with policies that make Berkeley like a great educational experience and a great life experience for you. But it is a place that's big, and so you have to know things in order to get the most out of them. And advising staff can help a lot for that. So one question is, who do you ask if you have a question? Well, EECS advisors know a lot about course planning, what happens if you need to repeat a course, what happens to your GPA if you do this and that. There's all these rules. And you might not care about any of them now, but you might one day. And they really know them well, and they can not only tell you how things work, but can advise you on what to do. And sometimes what to do involves like writing a petition to have the system work differently than it normally does. And they can help you with that too. So course enrollment, to make sure you can get into the classes that you want to get into, that's something you have to learn about this place as well. And advisors are good at giving you some guidance. Making sure you're on track to graduate, finding campus resources, research, and the honors program are all things that the department advisors help with. There are also advisors that are part of the College of Engineering, called the ESS advisors. They focus more on making sure that you will get your degree, and if there are any rules that need to change because of your particular circumstances, they can help you with petitions. So they're going to help make sure that you're ready to graduate. They can tell you about what the College of Engineering does and how it's organized. But most of the undergraduate experience is around departments rather than the whole college. So for most questions about courses and things like that, you'll want to go to the EECS advisors. But do be aware that ESS advisors know a lot about study abroad and various college level questions. And then you could talk to the faculty. Faculty all hold office hours where, we like to talk to students. And so if you're wondering, what classes to take for a particular course, go talk to that course instructor and say like, I know I want to take your class in 2 years. What should I do? Or I know I want to take it next semester. What should I do? Those are both fine questions. If you have an area of interest, like some problem you want to solve, but you don't actually know how that fits into the courses, then ask, because probably we could advise you. Like you want to do virtual reality, there's no course on virtual reality, I think. So which course should you take? Well, actually, there's an answer to that question, and you could ask. And you'll have a faculty advisor, which you'll get to select. And we have advising sessions where basically like you're asking questions, but there are other students in the room, so they get to hear the answers too, which is nice because you can hear what other people are asking. Oh, there's the picture of some of our great advisors. Yeah, this is the team. People have different roles. So you might run into them in different contexts, but they're all great. Somehow this department has managed to bring together just like an amazing team of people who are very good at their jobs and also care and are willing to not just like apply the rules, but figure out what's right for students. It's really a great team. So yeah, if you have a chance to talk to advisors, anyone on the EECS undergrad advising team, do it. But not all at once. Like, tends to be we get a little overwhelmed like first 2 weeks of the semester. So you might have to save your questions a little bit, and that's okay too. If there's something urgent, let us know. But if not, like, don't forget to follow up if for some reason things seem a little busy in the first couple of weeks, and you really want to talk about like, oh, I want to study this particular area. How do I go about it? Like, we definitely have time for that question. It's just if everyone asks at once, it's a little tricky. And that's about academic advising, which is really important, but your life and livelihood and mental wellness are really important as well. And it's really a challenging time in the world for all of us. Now, some people are inconvenienced by the pandemic, and some of us have experienced real tragedy. And college is also disorienting, even when there's a campus, but probably particularly so because of the online format. So if you're feeling like your mental health is under pressure, that you're having negative thoughts, you're having a really hard time, but college really does want to support you through that part of your life as well. And academics and mental health are closely related. They're not two separate things. And as much as you might want to split them apart, that's just not possible because everything's happening up here either way. So we do have a team of counselors that specialize in engineering students. So here are their pictures and their hours that they're available through basically like virtual counseling sessions. And then there's a campus level resource, the Tang Center, which is available Monday to Friday. And there's an after hours emergency consultation. So if things get really hard and you don't know, and you feel like there's no one to turn to, well, that's not true. There is this team and they're really wonderful. So yeah, so don't count them out if for some reason things get tough. Now I believe